Let's find the value of the given expression. We'll begin by first stating the De Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of n, then this becomes equals to cosine of n theta plus iota times sine n theta. So this is the De Moivre's theorem, or we can also write it in a compact form. So cosine of theta plus I sine theta can be written as cis of theta whole raised to the power of n. So this becomes equals to cis of n theta. So here cis represents cosine, the iota, and the sine. Right. Now we will simplify using the De Moivre's theorem of each of the expression present in both the numerator and the denominator. We will begin with the expression cosine of 2 theta minus iota times sine 2 theta. Now this can be also expressed as, now we know that cosine and sine, these are even and odd function respectively, which would mean that cosine of negative theta, that simply equals to positive cosine theta, because this is an even function. And when we have a sine function, this is an odd function, so sine of negative theta will be negative sine theta, since our sine function is an odd function. So we'll use this particular fact and rewrite our expression as cosine of negative 2 theta plus iota times sine of negative 2 theta. So in the compact form, we have cis of negative 2 theta. And this can be also expressed as cis of theta whole raised to the power of negative 2. Now that we have cosine of 2 theta minus iota times sine 2 theta whole raised to the power of 7, that means we have cis theta whole raised to the power of negative 2 multiplied to 7, which is simply cis of theta raised to the power of negative 14. So let this be number 1. Then coming to the next expression cosine of 3 theta plus iota times sine 3 theta raised to the power of 5. So this becomes equals to, so here we'll have cis of theta raised to the power of 3. This is from the inner expression, and this will be raised to the power of 5. So that means 3 times 5. So we have cis of theta raised to the power of 15. This becomes number 2. Then we have cosine of 5 theta plus iota times sine 5 theta. So this becomes equals to cis of theta raised to the power of 5. And since we have whole raised to the power of 3, so this becomes simply equals to 5 multiplied by 3 in the power. So we have cis of theta raised to the power of 15. So this is number 3. And our final expression cosine of 7 theta minus iota times sine 7 theta. So this becomes equals to cis of theta raised to the power of negative 7, and this is whole raised to the power of 2. So this becomes equals to cis theta whole raised to the power of 7 times 2 will be negative 14. So this is number 4. So that means our expression can now be also expressed as, so we have cis theta raised to the power of negative 14 multiplied to cis theta raised to the power of 15, positive 15, divided by cis theta raised to the power of 15 multiplied to cis theta raised to the power of negative 14. So we have all the terms factoring out from both the numerator and the denominator, and the final value of this particular expression is going to be equals to 1.